How's it going over
I
there?
sure do. They are going to let me actually do some code. I am pretty excited here. Let me pull this out here because I can hear too many people right now. But one of the cool things is that now it's the lunch break. Okay, they're telling me I'm good now. But we're going to do some AI stuff because I feel like AI is kind of the cool thing right now, but I feel like also a lot of people are kind of struggling with what it is that it actually does. And I'm going to show you today what it actually does and that it's actually really simple to get started. So I'm just going to open Visual Studio here and show you like from scratch, like that's really fast. And then what I'm going to do is I'm going to open this project and then we're going to get into a little bit about what we're going to do. I have just a couple of slides. Oh, look, see, look, the Visual Studio, I have the release candidate installed right now. And so notice that it loads up pretty fast. Everything's in there. Let me show you the application we're going to build. And then I'm going to show you how Visual Studio helps me out with that. Let me make my code a little bit bigger here. Let me go to, I think, 150 so you can see. Very good. So that's all set up. And what I'm going to do now is I'm just going to run this. And this, I'm going to go all the way back to old school. This is like WinForms stuff, okay? So this is a WinForms project just to show you that AI does not care where it runs, okay? So I'm going to run this program and show you like what it is that we're building. And I'm going to show you the two functions that we have to actually build in order to get this to work. And we're going to be building some Python. It's going to be really cool. So notice that this here is a program. And I'm going to draw with my finger a number, and then we have to recognize it, but notice that nothing happens because I didn't write that bit yet, and that's what we're going to do. So if we go to this old school WinForms application, you can see there is a predict and there is a load model. Now, here's the thing about machine learning that's really cool. When you think of an AI model, literally all you have to think about is think of it as a function. I'll give you an example. When we write programs, we usually think of a problem, and then we come up with a series of steps to solve the problem called an algorithm. And what we do is we marry an algorithm and the input, and out comes some answers. Machine learning is a little bit different than that, right? And by the way, I'm going to take your questions as well, so make sure you get those in there as well. Machine learning is a little bit different. What we do is we simply swap two things. Now, instead of getting the algorithm as part of the thing that goes from the left-hand side, the algorithm is the thing that comes out of the right. So what's happening is, basically, for machine learning, you're giving a bunch of answers and the right input, and then it learns the right thing to do on its own. And so, by the way, in machine learning parlance, we call the thing coming in data. I think everyone calls it that. And the thing that comes out is a model, but you should think of it as a function, something that you execute. And then stuff happens in here. I'm not going to get into too much of this stuff. I want you to see the boundaries of what comes in and what comes out to show you how to actually use AI inside of a .NET program. Basically, we want something like this, right? We want an int get digit, and we want to pass in a picture, and then we want a number to come out. Now, basically, when you saw this, I don't know if you saw this here when I ran it, because I wanted to show you what the input looks like here. So I'm going to draw the number 3 and hit recognize. In the output window, you should be able to see here what it is that the computer actually sees. This is what we're giving the machine. This big long string. And if you squint enough, you'll be able to see into the matrix that is exactly the thing that I drew. Do you see that if you squint at it? So that's what we're giving the computer. So if you think of the input, that's the picture we're giving the actual computer. And this becomes important when you train these things because I want you to see what's going on. Now, as we go, I want you to notice that the tool is going to start to melt away and become super important to what I'm doing, right? And this is, hopefully this will become apparent. Okay, so I'm going to go back over here. We want to get a picture in there. We want to pass out a digit. In general, machine learning is all about creating some function, and you have to specify the shape and do all this other cool stuff beforehand. But you get this function, you pass in these numbers, and out comes the actual number, right? And again, the things that goes in is that huge array of numbers. Okay, so that's it for my slide. So what I'm going to do is I'm going to code this the way I would normally code something like this, okay? So I'm going to do this. I'm going to right-click here, and I am going to add a new project. And this is the thing that I want to show you, because this is where the tool starts to show up and be really cool, right? So notice that the first thing, here, let me go over here. The first thing is that it remembers some of the stuff that I've already done. And I want to do a Python application. The other thing I can do is I can go in here to the language and pick the language that I want. Or I can go to search for whatever templates I want to. I can pick the platform. I can pick the project type as well. And one of the cool things you see here is it also has one for machine learning. There's some default scikit-learn projects that you can just by default start running. And I love how fast we can get to doing the thing that we want. So I'm going to go ahead and select a Python application, because that's generally how I do my AI. And I'm going to call this the Terminator for no good reason. And I'm going to hit create. And so now notice that I'm actually in the same solution working on both Python code as well as C# code. Okay, so now, as you know, if we want to write some machine learning code, we're going to have to do some internet sleuthing. And so I'm going to say PyTorch MNIST here, MNIST, because that's the example. Hopefully there's an example that I can do. So here's one. This is the first one. Notice it has the same numbers that I have. And okay, so we have some code here. So what I'm going to do is I am just going to copy it, because that's what some of us do sometimes. And I'm going to go ahead and paste it. And I am just going to run this code as is, okay? Now again, notice that I'm using Visual Studio. Next to this, you can see I have the code side by side, both in Python and in .NET. And what I have going on here, let me put this back so that they're all next to each other. What I have here is I have the actual code to run like digit recognition, okay? But there's a couple of things. For those of you that are Python users, this is argparse. Notice that there's some arguments that I want to pass in. Well, how do I do that? The other thing is, like, if you're a Python developer, you know what version of Python you're running. How do you know? Because, by the way, I did not have Visual Studio. I repaid my machine a couple weeks ago, and I installed my Python environments the way I like them first, and then I installed Visual Studio. And look at this goodness right here. So I'm going to make this a little bit bigger for those of you that are Python developers. Look at this. It knows all of my environments that I previously set up. Here's ones for TensorFlow Actual, TensorFlow 1.12, TensorFlow new version 2.0. This is using the PyTorch latest version Conda environment. And notice that the Conda environments are not the ones that Visual Studio installed. In fact, I went in there and I said, don't install yours, use mine. And they were like, we're good with that. And notice that we have all of that goodness in here. Okay, the next thing I need to do is I need to run this thing, right? But I want to save this into a format that actually works. And so I'm going to go down and scroll here. Notice that we have some saving stuff here. I want to save this not into a PT file, but into something called Onyx. And again, Onyx is, just think of it like as a DLL or as a jar file. It's a way of encapsulating an AI algorithm, okay? So I want to save this to Onyx. And like I said before, what we do when we write code is we need to go and actually do some internet sleuthing. And you can see here that I have already done some internet sleuthing and found a way to save something to Onyx. So I'm going to go ahead and I'm just going to copy this here real quick. And I'm going to go back here because no one ever does this kind of coding, I don't think. And okay, so I notice the format's a little wrong, so I am going to do this. Okay, I think this will work. So let's go to the Solution Explorer, and we need to give it some actual, remember we had to give it some things to do? So there's the working directory. Let me zoom in so you can see. Like all the stuff you would expect to run a Python application. But to debug it, we need to pass in some special script arguments. So let's go and see what they are. Epochs is the number of loops that it needs to go through. I am just going to do 1 for now because I want to make sure that this all works. So let's go to the Terminator code here. Epochs is 1, and then I'm going to go here and I want to actually save the model to a file. So I'm just going to hit save. I'm just going to make sure that the save model is in there. And now I'm going to save it, and I am going to set this as the startup project, and I'm going to run it. Okay, just like we would any other thing. Notice that it starts to run, right? Everything is going in there. You can see everything is starting to get in there. Hopefully it'll, let's see, let me go back here to the terminator. All right, everything is running, right? You can see everything's hunky-dory, just like I would do anything else. Right now it's learning from a bunch of digits that it downloaded, and it's going through the freeze epoch. And the reason why I do this, because again, I just downloaded this from some random code in the, So it looks like we have a problem. Oh, Onyx is not defined. Now here's the thing. I kind of did this on purpose because this is just what I would have expected if I was running it in C#. Except for I was dumb and I forgot to add something. So let's go up to the top because I forgot to add this import statement like a goober that I am. So we're going to go ahead and stop here and go up to the top and add this up to here, number 1. And there's another error that I saw here. Like, I don't think this file exists. So I'm gonna call it the CNN model .onyx here, and we're gonna make sure to do this one more time. So I'm gonna run this one more time, and hopefully it works. Crossing our fingers. I'm crossing my fingers right now. So as this goes, again, notice that something bad happened, a breakpoint stopped right where I wanted it to stop, and I know exactly what's going on. This is the same thing that I would have done, at other times with C#. And this is cool because I've never ran Python inside of Visual Studio. Oh, dang it, looks like something else is going on. So let's look at this X here. Let's see. Oh, look at that. I think I see it. So it looks like it's expecting a 4-dimensional tensor, and instead I passed it a 1-dimensional tensor. Let's fix it. So let's go here and say X, and we're going to use some PyTorch here. We're going to view -1, and we're going to do a view -1, and we have one channel, 28 by 28, and that's what we want. And now if you're thinking about what the heck is he doing, it turns out that when we give it a lot of pictures, right, if you think of a picture as a set of pictures, that's the first value here that we're doing. How many are we giving it? I put a -1 in there to tell it just whatever's left over. 1 says there's one channel because there's only grayscale. 28 by 28 is the size of the pictures that we're giving it. And I think this part will work. Okay, cross my fingers one more time, and I think we got it. Now, again, the cool thing about this is that I'm debugging and I'm doing everything exactly the way I thought I would have done it if it was C#. So as this goes through, it looks like we're at 60, 70, 80, 90. This should all save correctly. Boom, we saved it. Everything is looking happy, and let me show you what it is that we're actually saving. So let's go to Open Folder and File Explorer, and let me click on this thing called the CNN model. And you're going to see that, again, it's just a function, but that's formatted in a very funny way. The input that comes in is those 784 numbers that you saw from the code I ran before in WinForms, and then a bunch of stuff happens, and out comes this thing that's 1 by 10, which means that the output is going to be 10 wide. And what's going to happen is in that array of 10 things, there's going to be a number in each slot that says which number it thinks it is. All right, so now the question is, we've already done that. I actually trained a smarter one. You can see this Onyx one is smarter because I actually trained it for a little bit longer. And so that's the one we're going to use. So now we're going to switch over to Visual Studio. I've just trained this thing. I'm sorry, we're going to switch over to C#, and we're going to start to load the model. I've already written some of the helper code down here to initialize the canvas and all the buttons and to show results. So what I'm going to do here is I'm going to start by writing this thing called an inference session, and we're going to call it session. Now here's the thing, and you're probably wondering, well, where does this even come from? Well, that's a good question. What I did beforehand, I'm going to set this one as the startup project, is I added a NuGet package. Anytime you do something in Onyx, you can run this thing in .NET called the Onyx runtime. And what the Onyx runtime does is it allows you to load up files, Onyx files, as if it were something to execute, and then it executes them. And so we're going to go ahead and figure out how to do that the same way that anyone else would. So I'm going to do this here, session equals new inference session. It knows about that, and it looks like it needs a file. So we're going to give it the file. There we go, and that's it. we're going to make sure that the output, the text box up here, let's see here, so we can tell that it's loaded, the URL is loaded. So text URL dot text equals loaded. Okay. So let's make sure that works, and let's see what's actually in there. So I'm going to run this here and set a breakpoint like we would any other time. So let me load up the model here, and we want this one right here. And you can see that it's loaded. And let's take a look at what's actually in the session itself. And this is the cool bit, right? So notice that we have the input metadata. And notice that, hold on, let me open it up a little bit more, and let me zoom in here. Oh, it disappeared too soon. I'm actually going to do a quick watch. So let's do a quick watch here. And let's zoom into what it is that we're actually loading up. Notice that the input metadata is this thing on the 0. Notice that it says 0. Now, for those of you that were paying attention, when you looked at this, you remember that in the project itself, let's go back to that. Sorry, not this one, projects and numbers. You remember that in the actual project itself, when I click on it, the initial node that we had here was labeled as a 0. The output node, you recall, was labeled as a 22. Why it named it that, I don't know. I can't give you the answer to that. So if you ask, I'll be like, I have no idea. But notice that it also knows about the output metadata. It's labeled as number 22. Now, what is it that we can do with the session? So let's go over here and let's, oh, no, we don't want to do that. So let's hit close. And let's go one more time to the session. Let's do a quick watch. And we'll say session dot. Notice that there is one thing you can do, and that's run. And in the run, notice that it takes these things called named Onyx values. All right, so let's see if we can get that bit to work. So this is all loaded up. You can see that it's loaded, but we still need to do the recognition, which we haven't done. Okay, so the first thing we're going to do is we are going to go to the predict area, and like I'm free coding this, okay? So there's going to be mistakes, and that's okay. So the first thing we need to do is, now that we have this session, is we have to actually run this digit code. So what I'm going to do first is I am going to go ahead and say session.run, and let's see what it needs, because I'm not even, okay, it needs a named Onyx value. So let's see what that is, named Onyx value. And it looks like, let's do dot, looks like you can create from an actual tensor, float. Okay. And it looks like we need to give it a name, and the name is going to be 0 because that's the thing that needs to go in. And now we need to have a tensor. All right, so let's see how we do that. So in .NET, there is this new data type called a tensor. So I'm going to say tensor, I'm going to say var of x equals new, and there's a thing called a dense tensor of float. And what we're going to do is we are going to say it's of digit.length. Okay, and then pass that in. Okay, so now we have x here. Looks like we can pass that. We have this named value, so this is going to be the input equals, and now we can actually run the session. So let's do this. So let's do, oh, I forgot. I switched from Python there real quick. So we're going to say session.run, and I only have 10 minutes. So we're going to get through this, session.run. And I am going to pass in an input, but it looks like it needs a collection of it, so I'm going to do this goodness here, input, right? Because it might have more than one input. Okay. Looks like it's happy, and then we're going to say var output equals. Okay. So I'm going to set a breakpoint here because one of the things that's important is notice that this tensor does not have this data, so let's fix that too. So for int I equals 0, I is less than digit.length, and then I plus plus. What we're going to do is we're going to say x.I gets digit I as well. Now here's the thing that's important, is it expects it to be in 255. It expects it to be a value between 0 and 1, and you remember when we were doing the output, we saw 255, so we'll just divide by 255, because that means it's the darkest color. Okay. So let's run it and see what happens, okay? So I set a breakpoint there to load, so let's run it, and let's see what happens, because I want to see what's going on. So first we've got to load the model, because if it's not there, it won't work. So there it is. Now I'm gonna draw the number 3, and I'm going to recognize. Okay, so it worked, but we don't know what's in here. So let me do a quick watch here to show you what's going on, because again, this is how I like to code. Looks like there is a 0 element. So let's go here to 0 and see what that, oh, looks like it doesn't like that. And the reason why is 1, 2, 3. It's a read-only collection, so we got to do first. We can do that. And what's in there? When I go down there, it looks like there's a value in there. That's awesome. Looks like it has a name of 22. So let's see what I can do. Looks like I can pull it out as a tensor. So let's do that, and let's see if that, no, doesn't like it. And the reason why is because I need to tell it it's a float. By the way, does anyone else code like this? Notice that I'm now getting the value that I want, and I'm going to convert it to, let's see if I can convert it to an array, because that's easiest. Okay, so to array. Okay, good. So I've got all of this code that I've figured out, and what I'm going to do is I'm just going to do dot and just do this, and now I'm going to go back and see if I can rewind a little bit. Uh-oh. So it looks like it can't. Oh, the reason why it can't is because of this. So now we can save it and then go back here. 1, 2. Okay, looks like it went back, and now when I hit F10, let's see what happens. What do we get? A float of 10, and we get these crazy numbers. So this is what I'm going to do. I'm going to go back one more time and run it again. But now I am going to do this output, which is show. I want to show the result. So show result, and we got to do a prediction here. So how do we do a prediction on an array? Well, we want the max index. How do we do that? So I'm going to do this. I'm going to say var prediction equals array dot index of, and then we're going to pass in the output, and then we're going to get the output dot max, because this will give us the index with the max, and that's the prediction. And so now when I say show result, I can pass in the prediction, and I can pass in the scores, which is the output. I'm going to put in 0 just because that's how long it takes. We're going to run this again and see what we got. So I'm going to F10, 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 F5, and hopefully you will, there you go. Looks like it predicted the number 3. That's awesome. Now you're probably looking at these numbers thinking, what in the heck is this doing? Well, let's do some side-by-side exploration here to give you a sense of what is actually going on. So I'm going to do a new vertical group, and I am going to hide these things so you can see what is going on. So it looks like here, I'm going to move this one over here so we can do side-by-side the other way, and this one over here. Very good. So notice one of the interesting things that when we're loading this data up, they're doing a funny thing here. Number one, they're normalizing the data, which I did not take into account. So we need to fix that. So let's go see if I can figure what this is. So let's go to PyTorch, boom, transform.normalize. So it looks like it figured it out. So we'll go here, and then I'll normalize. Oh, here we go. So it looks like what this does is this subtracts the first value and divides by the second. So let's do that to make sure our output is real good. So very good. Okay, so it subtracts the first number, which is this number right here, minus this, and then divided by this. Okay. Okay, so it looks like there's something right here. So that's going to make it a lot smarter, number one. And then number two, the other thing that's interesting is like those numbers are really weird. I'd rather it give me like a probability of how confident it is. So what I'm going to do is I'm going to go up here to this code, and I'm going to look at this here and see what this is actually doing. By the way, again, hopefully you notice that I'm doing things in Visual Studio that you would never think about doing in Python. I just hovered over it, it's telling me. So this is the same as log of the softmax. And so what I'm going to do is I'm going to say e to that power, and it should give me something. Because remember, the opposite of log is e, and you can flip them around. So let's fix that. So I am going to do this, because I was very clever ahead of time. I put that in there, a conversion. So I'm going to say v goes to system.math.exp of v. But then I'm going to be even more clever, because, you know, we like to be clever here. So let me hit save here, and let me move this over to the middle of the window here. You can do something really cool called using static. So using static system.math, boom. So now I can get rid of this thing right here. And notice that because of the way lambda expressions work, I can also just get rid of all of this. All right, let's run it. Boom. With 3 minutes to spare in C#. Let me load the model here that I just created. And now I'm going to start to draw some numbers and then hit recognize. And you should be able to see, oh, there's a breakpoint, F5. You should be able to see that it's guessing the right thing. And now with probabilities, hey now, 99%. 99%. All right, let's do some other numbers. Let's do the number 1. Recognize, yes, it got that. The number 2, recognize, yes, it does that. The number 3 we already did. The number 4, let's see what we got. The number 5, what? It's a genius. 8, recognize. The number 0, yes. So notice that what I was able to do in Visual Studio 2019 is I was able to create a solution that actually depicts what I'm trying to solve with a number of different languages at the same time. Hopefully you enjoyed that. I obviously released the source code so you can play with it. But what I'm going to do is I'm going to get up and I'm going to go over here to take any questions because my time is about up. But I want to answer any questions that you might have. Okay, 13 new posts. There's no questions. Everyone, look, I know that these, yes. Auch beim Thema, machine learning, haben die Jungs ihren Strage. I was totally perfect German. I feel bad. By the way, for those of you that want to learn more about that, obviously we have tons of content to help you with that. But the key takeaway was, in Visual Studio 2019, I was able to seamlessly create a machine learning model and use that to actually make predictions inside of a .NET application. It was pretty amazing for me. All right, before we go, I want to make sure there's no more questions. Oh, look at this. Great, great, great. Yes, thanks. Thank you. My friendship dues will be sent in via check in the mail, so we'll make sure to do that. Again, machine learning, the key takeaway is, we only have about a minute left and then we're going to go to the next session. The key takeaway is that it's just a different way of writing an algorithm. Instead of you coming up with the steps, you give it the data, and Visual Studio 2019 is an amazing tool for you to actually do that, both in Python, in C#, and whatever language you choose. Okay,